Thank you. All right. So does everyone have their worksheet? Super duper. All right. So, oh, this is not connected to the projector like I thought it was. That's a problem. It's opening. All right. Sweet. Okay, so we have already gone over how to solve logarithmic equations. Now we're going to go over how to solve exponential equations. So what's an exponential equation? That's when you are like raising something to the power, right? So like here you can see we've got 2 being raised to the power here. Now, there's a couple of different kinds of equations you can get. The first kind is if you have something of the same base or something that you can get in the same base, okay? So if you look here, do you see how both of these are both like 2 to the power of something? Does everyone see that? So these guys are actually already in the same base. Good. Now, this is what I would consider like a very easy one of these because it's already in the same base. We're going to see ones where they aren't in the same base and you got to do some work to get them in the same base, okay? Which we've already kind of done, right? Like we've seen, okay, you know, if I have like a 4 and a 16, I can get the 16 to be 4 squared, right? That's essentially what we're going to be doing. So here, if we have the same base already, all we need to do is take the exponents and set them equal to each other. Okay, so we're going to do 2x plus 2 is equal to negative 2x minus 1. Questions on this so far? Now, all we need to do is solve this. So go ahead, solve this equation. Is this quadratic or linear? It's linear, right? So we just need to get all the x's on one side, all the constants on the other, and then solve for that x. So first, I go ahead, I'm going to add 2x to both sides. Then I'm going to go ahead and subtract 2 from both sides. If you did this differently, there is, you know, multiple ways to isolate the x. As long as you end up with the same answer as me, you're good to go. Then I subtract 2 from both sides. I get 4x equals negative 3. I divide by 4, and I get that x is equal to negative 3/4. Questions on this? Yeah. So you did something wrong somewhere. So I would look at how I solved this and try and figure out what algebra mistake you made, okay? All right. Okay, so now if we look at number 3 here, are we in the same base? No, okay? But we can get this in the same base, right? What base do you think we can get both of these into? 5. Very nice job. So we know that 5 squared is 25 and 5 cubed is 125. Do you all feel okay with that? All right. You do need to be somewhat familiar with like, okay, that looks like it's a base 3. That looks like it's a base 5. That looks like it's a base 6. You do just kind of have to intuitively know that. And I'm hoping that by now, right, like if you see 81, you're like, oh, that looks like a base 3 or a base 9. You know what I mean? So hopefully we're getting to that point, okay? And if you are struggling, I would just start listing them out, right? Be like, okay, well, I know these are base 2 numbers. These are base 3 numbers. These base 4, honestly, I would just go to base 2. Does that make sense? And then, you know, base 5, base 6, base 7, and then 8, you could do base 2, or you could leave it in base 8. Okay, so anywho, what we're going to do is replace this 125 with 5 cubed. So I end up with 5 cubed raised to the power of 2p plus 3. And then I'm going to replace 20. Oh, thought I was highlighting. I'm going to replace 25 with what? What do we think? 5 squared. Yep. So we're going to put a 5 squared there. Questions at this point? Now here we have to use our rules of exponents. I guarantee you one of the biggest mistakes kids are going to make is they're going to forget to distribute this 3 here, right? When we raise a power to a power, we multiply. This 3 needs to get distributed to everything in the exponent there. So we end up with 5 to the power of 6p plus 9.
Also, we have to do it to everything.
Yes. Yes. No. At that point, you've got the parentheses can go away because you've distributed it. I mean, it's not wrong if you leave them there. Like I could throw in parentheses here, but it doesn't like do anything, you know? All right. So now, do you guys see how this problem is pretty similar now to problem 1, where it's all in the same base? So what do you think we should do? Set them equal, right? Set the powers equal to each other. So we're going to say 6p plus 9 equals 2. Good? So go ahead and solve that. Bless you. So to solve this, I'm going to subtract 9 from both sides. I get 6p equals -7. I divide by 6, and I get that p is equal to -7/6. Feeling okay with that?
-7/6.
Yep, -7/6. All right. Let's see. Let's go and try. Let's go to number 7. Okay. All right. So there's a couple of different ways we could get these in the same base here. Okay. Does anybody have any suggestions? Ari? Okay, so you're thinking base 8. Yes, we could do base 8 here. What other base could we do? So we can write 64 in base 8.
Maybe do like 1/8 and then just do like a minus exponent, like a negative exponent.
Exactly, yes. So that's going to be getting it into base 8. Does that make sense? Like we can write this as 8 to the power of something. We can write this as 8 to the power of something. Is there another base we could use if we wanted to? 2. We could use base 2. All right. I guess it seems like most people want to do base 8, so we'll do base 8. But does everyone see that we could do like 2 to the 3rd, and then I don't even know what does that end up being? 2 to the 3rd, 64. It's early in the morning. All right. So first off, we know that we can rewrite this. We know that 1/8 is equal to 8 to the -1. Do we all feel comfortable with that?
Yeah.
All right. So we're going to write that as 8 to the -1. Then how could I write 64 in base 8? 8 to the power of 2. Good? So now I'm going to go ahead and apply my power or my rules of exponents. When you raise a power to a power, you multiply. Yeah. Place the A. We didn't. We replaced the 64 with the 8 squared. All right. So this became this. The A just stayed there for right now. All right. All right. So now we're going to go apply our properties of exponents, which means we're going to multiply. So we get 8 to the power of -2a minus 2 equals 8 to the power of 2a. Questions on that one? All right, what should we do now? Set them equal. Very nice job. So we're going to say -2a minus 2 is equal to 2a. Go ahead and solve that equation. So I added 2a to both sides, so I get negative 2 equals 4a. I'm going to divide by 4, and I get that a is equal to negative 2 over 4, which simplifies to negative 1/2. Yeah. That is a great question. We do not. You can end up with a no solution, but that is actually we'll do one like that, but that's not from checking for extraneous. It's like you solve. Do you guys remember like in math 1 when you'd solve a linear equation and you'd end up with like infinitely many or no solution? That you can have that happen, and we'll do one like that. But we don't have to go back and plug these in. Very, very good question. Yeah. You should simplify it. Yeah. All right. Let's see. Why don't you guys, I want everyone to go try number 9. Give this a shot. And these kinds of questions there's usually, I would anticipate at least one of these on the ACT. All right. Those of you who are interested in going to college. Yeah. Just make sure you guys put them back in this bin, okay? They're actually not mine. So yours, yours takes batteries, right?
Yeah.
Okay. I know. No, that's fine. But I have a lot of kids who are like, mine's not charging. I'm like, well, it takes batteries. Yeah. All right. All right. What base did we get this into? 6, right? So we know that 6 squared is equal to 36. And we know that 6 cubed is equal to 216. Does that make sense to everyone?
Yes.
So we can rewrite 216 as 6 cubed. And we can rewrite 36 as 6 squared. Good? So now we can go ahead and distribute this. We get 6 to the 6 minus 3k equals 6 squared. Questions on this so far? Now we've got the same base. We can set the exponents equal to each other. So we've got 6 minus 3k equals 2. We subtract 6 from both sides. And I get that negative 3k is equal to negative 4. I go ahead and divide by negative 3. And I get that k is equal to positive 4/3. Questions on this one? All right. All right, why don't you guys try number 11? See how far you can get. I will say the final answer here is wonky, but see, you can make some progress. Does that make sense? So go ahead, see how far you can get. What base should we maybe get this into? I think 8's a good goal there. We also could do 2 if we want to be adventurous. All right, were we all able to get to this point? All right, and then we go ahead and set these equal to each other. So we get that 2b is equal to 2b minus 2. All right, we want to get all of our b's on the same side. We subtract 2b. We get that 0 equals negative 2.
Subtract 2b.
Yep. What's the problem? 0 doesn't equal negative 2. Okay, so this is no solution.
No solution.
Uh-huh. All right.
No solution option for these problems.
Yes. Now, if you guys think back to like math 1, right? If you were to like plot these out, do you guys see how these are parallel lines? Remember, like you have the same slope, different y-intercept? Is that ringing a bell a little bit? That's why this ends up being no solution, because they're not going to cross ever. Okay? Can you kind of do you want me to graph it to see it? Like here, I'll graph it, I guess. Why not, right? We'll go to Desmos. So if I go ahead and graph this, right, if I say, I'm just going to use x instead of b, okay? So if I do 2x and then 2x minus 2, do you see how these lines are never going to intersect? That's why there is no solution there, okay? So if you get something like this, where you get that a number equals another number that is not equal to it, that means that you get a no solution, okay? Questions? All righty. All right, so let's go ahead now and we're going to move on over to this second group of problems here. All right.
Second page.
Yep. Let's take a look here at, I guess I should have put this one first. Oh, well. Let's take a look at 21. Okay. Now, these problems are, I guess looking at this, what's the problem here? Compared to what we were just doing. Ari? Correct. You cannot get them into the same base. Very nice job. Does everyone see how you're not going to be able to get 63 into a nice base 10? Now, I will preface, I'm only going to give you problems like these that are base 10 or base E. Okay? Now, you're like, well, where did that come from? Well, if you guys think on your calculator, you know how we have a log button and we have a natural log button? Okay, that's why. In theory, you could like do this with other bases. You can plug it into your calculator and make the log have a different base. But with these kinds of problems, they're either going to be base 10 or base E. Okay? All right, so bear with me here. What we are going to do is we're going to do the inverse operation of raising of an exponential, right? Do you guys remember what the inverse of an exponent is? It's a log. Okay. Remember how we showed that like when you flip the x and the y values, they're inverses? Remember that long video y'all watched? So to undo 10 to the power of something, we're going to take the log of both sides. Okay. So we end up with log base 10 of r equals log base 10 of 63. Now we don't write log base 10. We just do log, right?
Yeah.
Questions on this? All right. Now, if you recall on our properties of exponents, if we have or I should say our properties of logs, if we have an exponent, where can I pull that to? Read. Yeah, we can pull that out in front. So we've got like r times log of 10 equals log of 63. Now, do we know what log of 10 is equal to? This is something I could ask you to do with no calculator, no real calculator, right? Think about what's the base here? 10. So it's saying 10 to the power of what gives me 10? 1. Okay? This is literally equal to 1. So I have r times 1, which is r. You guys see that?
So it's just log of 10 is just r.
Log of 10 is 1.
Okay.
So it becomes 1 times r, which is r.
R equals log of 63.
Yep.
Is that it?
So if I said I wanted this as like an exact answer, remember how we did that with the E? And I was like, we're going to leave it like this. If I wanted an exact answer, you would leave it like this, but the directions say to round to the nearest 10,000. So we're going to get out our calculators and we are going to type in log of 63. So you just click, oops, that's the LN, oops. We're just going to type in log 63. And that gives me 1.79934. So I'm just going to write that down and we'll talk about rounding in a second. Was everyone able to do this on their calculator?
Yeah.
We're all good?
Yeah.
All right. And then they said they want to round to the nearest 10,000. How many decimal places is that? 4. Very nice job. Because the decimals, it goes, your first one is your tens place, tenths, I should say. Then the next one is the thousandths.
Hundreds.
Oh, good job, Landon. I'm sorry, you're right. HUNDRETHS. Then we have the thousands. And then we have the 10,000s. Yeah, you good job. Good job, Landon. THOUSANDT. Do we all see how that works? Tenths, hundredths, thousands, 10,000s, then 100,000s, then millionth. Good. All right, so we need to round this to 4 decimal places, so we would cut it off here. And the 4 tells the 3 to stay the same, so our answer is 1.7993.
1.7. And that's just what R equals.
Yep. All right. Let's go ahead. Why don't we try maybe number 23? Okay. So what we can do here is, and I want to point out, we're going to do ones where we have to do extra steps before we go straight to the log. Do you see how in this case, the 10 to the power of something is by itself? There's nothing being added, nothing being multiplied. We just have 10 to the power of something. So when we have this, we can go ahead and take the log of both sides. So we get log of 10 to the negative 5.8x equals log of 49. Again, we can use our powers of our properties of logarithms. This comes out in front and we get negative 5.8x times log of 10 equals log of 49. What is log of 10 equal to? 1. All right. So this essentially goes away because it's times 1, and we get negative 5.8x equals log of 49. How are we going to solve for x here? Yeah, so let's go ahead. How about let's get everything on the same side and then we'll plug it in all at once. Is that fair? So to get x by itself here, what do we got to do? So good guess. We're going to divide. So it is, because it's a negative, it looks like you'd be adding, but since it's actually being multiplied with the x, so we're going to divide by negative 5.8. So we get that x is equal to log of 49. Oops, I don't know why I did that. All over negative 5.8. So we can just go to our calculator. We're going to do log of 49 divided by negative 5.8. And I get, and I'm going to just write it out before rounding so we can discuss the rounding, negative 0.291413. We got to round to 4 decimal places, so I cut it off here. My 1 tells my 4 to stay the same, so my answer is negative 0.2914. Questions? All right. Let's see. Let's do, I guess let's go to 33 because that's like a tough one. Okay.
3.
Yeah. Oh, actually, no. What the heck? I don't want to do 33. That's not a base 10. We're not doing that one. I lied to all of you. Sorry. Oh, I guess I didn't do any 2-step ones. That's fine. We'll go back to 25. Sorry. All right.
25.
Yep. So, what's different about 25? Read. Yeah. So, how about let's just get this 10 to the power of something by itself. What do we, so to get rid of that 2, what are we going to do? Subtract 2. So I get 10 to the power of n plus 9 is equal to 82.4. All right, questions? All right, so now we can go ahead and take the log of both sides. All right, and if you've noticed, when we do this, what happens is the power comes out in front. All right, we get log of 10. Oops. And this log of 10 becomes a 1. We all getting comfortable with that? So we get that n plus 9 is equal to log 82.4. Questions? So now how do I get n by itself? Fareed, we're going to subtract 9. So I get that n is equal to log of 82.4 minus 9. Now, when you plug this into your calculator, you have to make sure that you don't put that minus 9 inside of the log. Okay? Does everyone see that? So just be aware that you need to close that log off when you plug that in. So we're going to do log of 82.4, close parenthesis, minus 9. And we should get negative 7.084. Questions?
So why wouldn't you just subtract the 9 from the 82.4 instead of just like leaving it out?
So that it's not, it's kind of like, actually it's very similar to like this. Like if we did the square root of x minus 9 versus the square root of x minus 9. It's on the out. Does that make sense? Like it's on the outside of the function. Okay. So we can't just throw it in there. All right. Good. All right. Let's see. Let's go ahead and take a look here at 31. All right. So this one is E. All right. Now, to solve something like this, what we're going to want to do is get that e to the power of something by itself. What can we get rid of first? The 9. Yeah, let's get rid of the 9. How are we going to do that? Divide. So I get e to the 6x is equal to 67 over 9. I don't think that simplifies, does it? Okay, I would leave that then because it's repeating. Does that make sense? If it was just like 7.4, you could write it as that. But yeah, it doesn't reduce. So kind of ugly, but that's okay. So now we've got the e to the power of something by itself. So when we had 10 to the power of something, we did log of both sides, right? Because it's log base 10. Well, what's log base e? Okay. Okay, I guess. So how about natural log? you guys remember that? Like ln of x is equal to log base e of x. Does that make sense? So we're going to take the natural log of both sides. Good. So we get ln of e to the 6x equals ln of 67 over 9.
So we just do that.
Mm-hmm.
If it's E, then you're supposed to use the ln.
Correct. Then this comes out in front, and we get 6x ln, or times ln of e, equals ln of 67 ninths. What is ln of e equal to? We know that that's log base e, so it's basically log base e of e. What's that? 1. Okay, that is something you guys need to know, that like ln of e equals 1. You do have to have that down, right? Log of 10 is 1, ln of e is 1. All right, so then we get 6x is equal to ln of 67 ninths. How are you going to get x by itself? Divide by 6, right? So we get that x is equal to ln of 67 ninths divided by 6. So we go to our calculator. Do you guys all see the ln button? It's right below the log. Does anybody need help finding it on their calculator? TI-30s or something? Do we all see it? So we're going to do ln of 67 divided by 9. Close the parentheses, okay? And then we divide it by 6. How are we feeling with that?
So it's 0.3345.
Yep, so we'd round that to what? 0.3346. How do we feel with these? Yeah.
So you know that last lecture was 6.
Yeah.
Do you round that up because it's a 5 or like?
You round that up because of the 7. So if we have 0.334578, we're rounding to 4 decimal places. The 7 tells the 5 to go up. All right. Let's see. Why don't we try? I don't know. Let's go do. You guys pick. What number do y'all want to do?
30.
30? All right, let's go do 30. So what do we think we have to do here? Yeah, right? We need to get this e to the whatever by itself. So we're going to subtract 9.3 from both sides. So we get e to the n equals 47.7. Questions? Now what should we do? Lena. Yeah, very nice job. We're going to do a natural log of both sides. Okay, so we get ln of e to the n equals ln of 47.7. This guy comes out in front, so we get n times ln of e equals ln of 47.7. What is ln of e? 1. So this is just n.
So ln E equals 1, right?
Correct.
Perfect. And so does the log of 10.
Correct. So now we just go to our calculator and type in ln of 47.7. And I get 3.865. We'd have to round that too. Oh, wait, hold on. No, it'd be 1, 2, 3. Yeah, 0.49. My bad. Good?
Like that?
Yep. All right. I want you guys to try. Can you guys do 32 for me? Give 32 a shot.
Wait, so is it just whenever it's Eve, then we change it to LN?
Mhm. All right. So hopefully you subtracted 3.5 from both sides. We get e to the x plus 4 is equal to 18.5. We're going to take the natural log of both sides, and the x plus 4 comes out in front. We should end up with x plus 4 equals the natural log of 18.5. Did anyone struggle getting this?
X plus 4 equals just that.
Yep. And then we're going to subtract 4 from both sides, and we get that x is equal to ln of 18.5 minus 4. And remember to use the parentheses because that minus 4 needs to be kind of on the outside there. All right. All right. So now we go to our calculator. We're going to do ln of 18.5, close parentheses, minus 4. And I get negative 1.822. Did I do that wrong or something?
0.
Oh, thank you. Yeah. Sorry.
Point 1 and point 0.
Yep. So we get x equals negative 1.0822. 1, 2, 3, 4. Yep. All right. Are we feeling okay with this? Let's see. Manage. I'm going to stop this. Oh, here. Stop recording.